function notation.
I lost my pencil.
Okay, it's basically the exact same thing as y equals 2x minus 3. So we're replacing the y variable with like an f of x. So what does this little parentheses mean? It means the f value depends on what you put in for the x. So if they write like what's f of, well, let me use 4. That means what is f going to equal when I replace the x value with a 4? So all you do is plug in 4 right here. Have you guys done this before? You haven't? Okay. But does this make sense? If f of x equals 2x minus 3, find f of 4. F of 4 just means when we plug in 4 for x, what is this going to equal? So you just do 2 times 4 minus 3.
It looks like a minus.
Yeah, that's a minus.
Wait, then why are you doing 2 times 4 times 3?
Minus 2 times 4 minus 3. 2 times x minus 3.
Where's the 4 coming?
That's where I was.
Right here.
4 is x.
F of 4, I made it up. F of 4 means find the f value when you put in 4 for x. Okay, we're not really doing anything over here. This is just like the question. Like what's f of 4?
I got the question.
So you plug in 4 for x and then it's 5. So f of 4 equals 5. So what if I say what's f of negative 1?
What's 2 times 4?
1.
2 times negative 1.
2 times 4 is 8, minus 3 is 5.
Okay.
Maybe 1, right?
Negative 1.
No, 5. So on this one it's negative 1. So what are we going to do with the negative 1?
Minus 1. Wait, times it by 2.
2 times negative 1 minus 3. 2 times negative 1 minus 3. So this would be negative 2 minus 3. That would be negative 5. So all you do is plug something in. Okay, we're not really doing that much of this today, but it will come up later. They should have done it today, but I think they kind of missed the boat on that one. But anyways, does that make sense though? This is very, okay, it doesn't? All right, let's try again.
Even Luke's confused.
I don't know why we're doing this because that's at 23. We're going to 22. All the way through 22 is graphing.
23 doesn't do it right, so that's why I'm doing this.
Okay.
So f of x is x plus 4. So that means the f value depends on what you put in for x, and you're going to do x plus 4. This is not rocket science. If it's hard, you're just making more of it than it is. So if I say f of 2, what's that going to equal? 2 plus 4.
You just replace the x with
So it's just 6. Okay? Got it? Kenzie, I was doing this because of you and you're not even paying attention.
I got it.
Alright. Now, this lesson is not really mathy. It's got a lot of definitions and stuff. The first one, actually, let me, relation and function. So, this stuff that I was just writing, these are functions, but the definition of functions is broader than that. Okay, our relation is a set of ordered pairs. I mentioned this briefly yesterday, the term ordered pairs. Do you guys remember what ordered pairs are? That's what we were graphing yesterday. So yesterday when we had like 2, negative 3, this is an ordered pair. It's ordered because x comes before y, and it's a pair because there's 2 of them, right? So a relation might be like 2, negative 3, 5, I'm just making stuff up here. 6, 1, 6, -3, whatever. Actually, let me make this one too. Okay, this would be an example of a relation. Just some ordered pairs. Okay, the reason they're pairs is because there's some kind of relationship between the x and y. It depends on what we're talking about. Like, maybe it's one of them represents time and money or population or something, but there's some kind of relationship between these two numbers. Just depends on what you're talking about. Okay, a function is a relation where each x value not the technical definition, but that's basically what it is. Okay, no, but you don't necessarily need to write it, but we need to understand it because this is part of the assignment. Each x value has at most one y value in a function. A function is a relation, so it's a bunch of ordered pairs like this. It can be written like this though, because like if I plug in 2 and I get 6 as the answer, that's basically an ordered pair. Like when x is 2, the function is 6, so like 2 and 6. So they can look like this, they don't necessarily, they might just look like this. Okay, what does this mean? Each x value has at most one y value. Okay, this is not a function. Why is it not a function? Because the x value of 6 is getting paired with 2 different y values. So that's the no-no. So if I erased one of these, now it is a function. Got it? So each x value can only go to one y value in a function. This is still a relation, it's just not a function. Okay. Clear as mud? Okay. Each x value, so these are x values, these are y values. X, y, x, y, x, y. So the first number, x value, can only go to one y value. So if 6 is going to 1 and 6 goes with 3, that's not a function. That doesn't work. Okay, some more definitions. You guys have heard this one actually. Domain, do you guys remember what domain means?
Totally.
Then can you tell me?
Kingdom.
Okay, this is not the technical definition, but it's the
Math definition.
it's my definition. It's the x values. The domain is the x value. Domain are the values that you put into the function. They don't always use the same letters like x and y. They just normally use x and y, but domain is the numbers that you plug in. The range is like the y values. It's the numbers that come out. So you can kind of remember this because domain, what does domain mean? It means like your home. So that's like your starting place. And range, you like shoot on the range, so it goes towards something. So it starts with the x value and it ends with the y value. Domain, range. Okay, am I forgetting something? I don't think so, but let's do it.
Trick or treat last night.
Oh yeah.
That's fun.
Can I tell you it's gonna be SpongeBob SquarePants?
Where you at? I could see it.
That would be fun. I feel like his cousin.
What? Cousin what?
The one that like draws and stuff. Yeah.
Oh.
Yeah.
Are you talking about Patrick? What?
I thought we were talking about the snail thing.
Gary is
Larry.
Gary is the
There's
cousin.
a lobster.
Larry?
Larry the lobster.
Snail.
There's Gary. That's the
I don't
insane.
know. Ah, Gary.
Well,
I was a fat shark.
It's a snail that makes a meow sound.
It's a snail that makes it.
SpongeBob is so good.
The snail meows.
It does.
Yeah.
I've seen enough to know that. Yeah.
I've
Yeah,
never
yeah.
watched it.
You never watched SpongeBob?
I've seen like one episode of it on.
I've seen like 2 episodes, but I knew the Gary thing.
I've seen the one like every.
Okay. On number 1, these are really quick. Is that a function? Yes or no?
No.
Oh, sorry. Is it a relation? Sorry. Is it a relation? Yes. A relation is just a set of ordered pairs. Are those ordered pairs? Yes.
How are they ordered pairs?
There's 3 groups of 2 numbers. So they're pairs. Ordered pairs are just 2 numbers. Okay. Number 3, are those ordered sets of ordered pairs?
No,
No. Because what's wrong with number 3?
it's not even.
They're trios, not pairs.
I didn't see that.
So number 3 is no.
No boss.
No.
Okay, number 5, draw a mapping. Okay, we haven't talked about this yet, but it's not a big deal. So a mapping just means you draw a couple circles. The first circle is going to be, or an oval.
Does that have to be big?
Well, we're going to have to fit like 4 numbers in here. So
Oh, that's a lot of
Mr.
numbers.
Jordan.
the first circle is the domain, and the second circle represents the range.
Domain?
Okay, what did I say the domain meant?
Evens.
X values. So on number 5, what are the X values? -5,
5, 2, and 5.
2, and 5. Okay, now notice I did not write -5 twice. If it's a member of the domain, it only counts once. Okay, what does range represent? Y values. What are the
1,
Y?
2, 8, and 6.
1, 2, 8, and 6. Okay,
It's not a function.
well, we're not there yet. To represent the relationship, we're going to draw arrows. So, what does -5 go with? And
1.
goes with 1
And 2.
and 2. What does 2 go with? 8 and 5 and 6. Okay, is it a function?
No,
Why not?
because 5 is going to be 2 numbers.
Right. -5, you can't do a repeat here. It can only be used once. So, no, it is not a function.
Circles.
Wait, what?
I made it.
More?
We can go back up for a second.
Range.
Okay, on number 7, what's the domain?
1.4, 4.2, 6.8, and 8.4.
That's a lot of numbers.
You're in math.
Okay, and then what's the range? 3.2, 1.5, 1.4, and
Maybe lost,
6. All right, so the way that I wrote them is in order, so it's just going to be The top one goes with the top one. Okay, is this a function?
No.
Yes. Each x value only has one y value that it goes with. So, yes, it is a function.
Okay, so like on this one, since 6.8 is on there twice, if it was in the same like circle, would it not be a function?
You mean if you write a repeat number over here? If there's a repeat number, you still only write it once, like we did on number
Well, yeah,
5.
but then like it wouldn't be a function.
There's a repeat on the x values, yeah, it's not a function. If the x values repeat, that means one x value is going to two different y values, so it would not be a function. Number 9 says state the domain and range, kind of the same thing. So the book uses the braces. I don't really care if you use this or not, but what is the domain on number 9?
6, -9, 4, -5.
Is it 9 or negative 9? -9, 4, and -5?
-9.
-9? Wait, okay. So you only write -9 once, though.
I thought we had to draw the ovals.
That was a map. Those are called mappings. It's just set note. This is just set notation. What's in the range?
10, 14, 2, and 8.
10, 14, 2, and 8. It's getting a little bit warm.
Oh, he's freezing.
Speaking of.
Hey, there you go. Kinsey's.
That's not even open. No, that's you, bro.
Yeah, you're right.
You don't care.
It's gonna bounce off all my stuff. Mr. Keep an eye
Just barely open it because.
Just open it all the way.
No, barely. I said.
You gotta close it now.
on it.
Said barely open it
Why would you barely open it?
because Kinsey's cold. So
Bro,
Kinsey calling out. You need to suck it up.
we'll
Yeah, she
compromise.
can suck it up.
Maybe Allison doesn't want it blowing right on her either.
Exactly, you gotta open
I
it.
don't
Anybody.
I have a hoodie. It's like really hot.
Okay, that's blowing
Thank
out.
you,
That's
Allison.
blowing
Thank
away
you.
from you, Kinsey.
Oh,
Okay, is this a function? No. How could they tell? Because -9 appeared twice in the x values. Because -9 is going to two different y values. But that's not a function. We only wrote -9 once. Okay, number 11. What is the domain?
1.3, 1.4, 1.5, 1.6.
And the range is 3.7. Is it a function?
Yes.
Yes. Okay, it doesn't matter that the y values repeat. It only matters that the x values are not repeating. But yeah, x 11 is yes a function. Okay. 13. So we gotta say if it's a relation and a function. This is actually a matching section. We got three options over on the right.
What's the difference between a relation and a function?
Okay, what's a relation?
Set of ordered pairs.
Ordered pairs. What's a function?
A relation where each x value only goes to one y value.
Yeah. Each x value can only go to one y value. So basically the x's don't repeat themselves. So is 13 a relation? Yes, because it's a couple ordered pairs. Is it a function? Yes, because the x values are unique, 2 and 4.7. So it's relation and a function. It is option A.
Can a fraction be a function?
Fraction just like any other number. Okay, 15. Is that a relation?
No.
No, because it's not pairs, it just lists 4 numbers.
Is it a function though?
If it's not a relation, it can't be a function. So it automatically fails both. So it's C. My computer is screwing up. See how it writes this line like really... Fixes itself, I guess. Okay. 17, is that a relation? Yes, it's 2 ordered pairs. Is it a function? No, because the same x value is being used twice. So it's a relation that's not a function, so it is B. Okay, 19, we're not going to follow all the directions on 19. We're just going to say, is it a function or not? But they just write it in different ways. So number 19, we've seen this one before. Is 19 a function?
Yes.
Yes, because all the x values are different. They're not being repeated, reassigned. Okay, 20 is basically the same thing. They're just writing it in table form instead of in ordered pair form, but it's the same idea. 21 is that a function? So, mapping. No, because the 2 is going to 2 different numbers. So that's not good. Okay, 22.
Yes.
How can you tell it's a yes?
Because it doesn't have the same x value.
Right.
It doesn't have
If you think about the coordinates of those 3 points, the left one has an x value -2, -1, 1. All those points have different x values. So she said yes, and she was correct.
That's amazing.
If the points were stacked on top of each other, that would not be a function.
This
Because,
is easy.
yeah, because it would have the same x value.